Hello, in this tutorial I'm going to perform an image classification using random forest in Python. I have here a Sentinel-2 image with 10 bands, and this is going to be my input. So going for the code, first I would like to recommend using Python 64-bit because it lets you use more memory, and this is very useful if you are working with large data sets that consume a lot of memory. So go for the 64-bit. Well, the first thing we need to do is to import all these modules, and I'm going to provide the code in the description. After that, we need to set the inputs of the script. So we start by defining the path to our image. This is the original image, and then we define the path and file name of our output. I'm gonna call it output.tiff, and this is going to be the result of our script, the result of the classification. In addition, we need to define our training dataset. So in my case, I have a CSV file, and I'm going to read as a pandas data frame. Also, I need to set the separator, which in my case is the semicolon, and we are done. Now we can open the raster. Okay, it's done. And the next step is gathering some information, some important information, basically spatial reference about the original raster. We need this because when we proceed to creating the output raster, we need that this output has the same spatial reference and characteristics as the original. So we need the number of rows, the number of columns, number of bands, also and the projection. Okay, I'm going to print the number of rows, the number of columns, and the number of bands, so that we can check if we are good. So here in QGIS we can see the information about our image, and well, we can see that the numbers match, so we are good. Alright, next step is reading the image as an array. So that's it, and now we can close the image, and I'm going to print the array for you to see its shape. So this is the array. It's a 10-element array. For instance, this is the first element, this is the second, third, and so on. And each element represents a band. So this is the first band, second band, so on. However, this shape of array is not good for us because we need something in this structure. I will explain. So basically, this line represents a pixel, and it's an array, and each element within the array represents the band value. So we need, in the end, we need for the classification an array of this shape, this structure. So in order to achieve this shape, we need to perform a stack. So I will explain. What the stack does is, imagine that we have a 3-band image. In our case we have 10 band, but that's fine. So what the stack does is it gets the elements at the same position in each band and put them together in just one element. So let's say that this matrix here in the right hand side is the result of the stack of these 3 bands, and as we can see, this element here is the combination of the elements of in this position of each of the arrays. So you get the idea. So this is what the stack does. However, this is not enough, and we need to perform a reshape. Sorry, shape array. And this is the shape we want. Now I'm going to print the first element of the array after the reshape. So this is the first element. As you can see, we have this kind of structure. So I think we're good. And we can check in the image, sorry, as this is the first element of the array, this is the first pixel of the image, and here it is. So we can check the values. So 174, okay, 354, okay, 294, okay, so we are good. Back to the code. Now I like to transform my array into a pandas data frame. And the data type, in my case, it's int 16. Well, I do this because here in the beginning I am already working with pandas data frame, my training data, so I'd like to keep both test and training data in the same structure. That's why I'm using a pandas data frame again. So right now I can delete the array because I don't need it anymore. I already have the data stored in the test variable. And now we need to separate the training data into actual data, actual band values, and also separate into class labels. So first, and so on. So to save us some time, I'm gonna copy this piece of code and label. Copy. Alright, so this is my CSV file, and as you can see, I have the 10 bands here. Look at the name of the columns. They are here, and this column here represents the class label, and they are here, so we are good. And now we can delete the data frame, and the next step is setting the classifier. So here you can put your parameters. I'm gonna put just 53s for now, and jobs equals -1. This is going to force the program to use all CPUs. Okay, and now we can delete data and label. Okay, so this piece of code trains the classifier. So the next step is making the predictions. So what this line does is it takes our test dataset and predict for each record of the test which class it belongs to. So it assigns a class to a combination of band values. It's the actual classification. And now we can delete the test. We're almost there. We just need to reshape the predictions. And now we can delete. Okay, so this line actually puts the predictions in the same shape of the image, so that we can export the image with the same number of rows and columns as the original. And now we need to copy this function, which I'm going to provide as well, and just call the function here, create geotiff out raster classification geotransform projection. That's it. I think it should work. Predict, it was missing a T. Okay, it's finished. So right here in our folder, as you can see, we have the output, and we can open in QGIS. So this is the output. I can change the colors. I know this one is water, so let's put some blue. And that's it. So this is the result.